We're going to talk about dark energy. But before we can get into this dark energy business, we have to look at what we've been looking at lately, and that is mathematical physics. What is this mathematical physics? Is it physics? That's, I guess, the first question. And I've been pounding them lately, okay? What was it? Last week I talked a little bit about them, treated them as clowns. And yeah, they are clowns. And I don't take it back because I'm really not insulting them. They are clowns because, these celebrities, because they're not scientists at all. They're not physicists at all. What they do is entertainment. They're in the entertainment business. They make money not teaching science, because they don't teach science. They're there for entertainment value. And most people out there don't understand that. And they think, oh, I'm going to get my shot of science this week. I'm going to listen to, I don't know, Tyson or Brian Greene. And all they're listening to is nonsense. Now, these people don't tell them, when they have their shows or their interviews, they don't talk about equations. They don't say, let me show the equation for this and for that. Let me show you the measurements we made. No, they can't talk like that because immediately everybody would turn the TV off, change the channel, go do something better for that day. They're not going to listen to equations. None of these people, and you take my word for it, none of these people talk about equations. They all talk about the physical interpretation of the equation. They try to, reduce it for the layman. So they're there not to talk about equations, about numbers or measurements. They're there to tell you the conclusions. What does it mean? What is the bottom line? That's what they're there for. Okay, keep that in mind. That's important. Why? Because when you say, look, but that's irrational, what you just said, the explanation you just gave me, the physical interpretation, and they say, yeah, you're right. We don't understand it either. And you say, well, if you don't understand it, what kind of a physical interpretation is that? And they say, well, that's philosophy anyways. So why did they do that? Why did they talk about physical interpretation if they're going to dismiss it at the end saying, oh, that's philosophy, it's word wizardry, it's ontology or whatever? If physics is mathematics, measurement and equations, then they should stick to that and say, look, we're going to talk about equations, we're talking about the measurements we made, then they'd be talking, what they call physics. But that's not what they do. They talk about philosophy. When you question their conclusions, they say, well, that's physical interpretation. That's philosophy. We don't do that. That's not in our job description. What we do is equations. And so here you have the definition of a theoretical physicist. Okay, physics says employs mathematical models and abstractions of physical objects and systems to rationalize, explain, and predict natural phenomena. Man, they said a mouthful there. Just about every word is questionable there. First of all, physics is not about mathematical models. Mathematical models has nothing to do with a physical model. That's the first one, But then they talk about abstractions. Abstraction is the opposite of physical. So if you look them up, they're antonyms. Okay, but then they talk about physical objects. The only thing that mathematical physics doesn't have is objects. They treat concepts, abstractions such as field, wave, mass. They treat all these at time, They treat all of them as physical objects. They bend time. They move the mass. They transfer energy. They vibrate the field. They treat every one of these abstract mathematical concepts as physical objects. So again, we have a problem because they're talking about abstraction. No, what they're doing is they're using mathematics. They're using equations. They use measurements with their units, corresponding units, like the kilogram or the meter. And they're going to use the meter and the kilogram as a physical object. That's what they're doing. That's more than an abstraction. That's irrational. If you say that you're going to treat a ghost or a spirit and you say, look, there's a spirit and I'm going to draw him. You say, okay, he took this abstraction, turned it into something concrete because you can see it now. But to take an equation or a number, like or a value like 5 kilograms, and turn that into a rock, which is what these people do, turn it into an object, that's irrational. Okay, because now we're talking about more than just a concept that you can visualize like a ghost or an angel, and saying, well, I'm going to turn that into, the spirit, I'm going to turn it into something concrete. Here you're talking about a number being turned into a rock. Okay, so this is where the problem starts. But what does mathematical physics do? Well, they have equations. And what the equations do, all equations only describe. Equations have no power to explain. And so equations belong to math, and explanations belong to physics, to science. Physics tries to explain, not to describe. It's math that describes. Okay, and so we have, these people say that mathematics is the language of physics. That's nonsense. The language of physics is illustration. You have to illustrate the mechanism. You have to show the cause. That's what physics is about. But to describe and say, look, this lion ran so fast, or whatever, or the ball fell to the floor at such speed, or such acceleration, that's a description. You haven't told us the cause, the mechanism. Okay? And that's the issue. And so math is one thing, physics is something else. Math, quantitative description, it tells you how something happened, not why it happened the way it did. Okay? So one has to do with description, the other one with explanation again. Experiments cannot reveal, the invisible mediators. So the fact that you have taken a measurement and you have an equation, you have not revealed what invisible entity has performed this experiment or this phenomenon. The issue here is very simple. If imagine, I'll explain with a little example. You think there's a rat, and so you see something happening, and you say, well, it's a rat. The rat was here, the rat was there, the rat was there, and you see the rat at different places. It's an invisible rat, but it has these impacts, and you are able to detect the impacts of what it does to visible things, but you can't see the rat. You say, okay, the rat was over here. Now the rat was here, the rat was there. And you do all your equations, your measurements with the rat in mind, because that's what you think's out there doing all this stuff. It turns out that if you had the eyes of God, you would see that it's a snake. And each one of those blips was the contortion of the snake. So you were confusing many rats with one snake and the undulations of the snake. So the first task of a physicist is to try to figure out what invisible objects are out there before you go out there and do a lot of measurements and equations, because you don't know what you're measuring. You think you're measuring all these mice, these rats, and it turns out it's a snake. Or maybe it's a, fish or an eagle, who knows? First, you got to determine what object is out there. And people say, well, why does there have to be an object out there mediating all these things like entanglement, or gravity? You have to have one, because otherwise you're doing your explanation with black magic. You're doing witchcraft. You're saying that this affects that without anything being in between them. And worse, as long as you do it with nothing, that's quite irrational already. But to say that it's done with mass, it's done with field, it's done with wave, it's done with energy, then you're totally irrational, because now you're using a concept, a mathematical concept, as a physical object. You're putting it in between the two objects and saying, oh, this one transferred energy to that one. No, you can't transfer energy any more than you can transfer love. What do you do? Throw hearts at the other one? How do you transfer love? You don't transfer love, you don't transfer energy, you don't transfer concepts. You can't talk like that in physics. In physics, you got to transfer rocks. That we can do. But of course, if people say, well, that's not what's happening out there, there are no rocks, no discrete rock, well, then we have a problem, don't we? Then you can't use the rock as a mediator. Okay? But these are the things that we have to resolve. Okay, so yeah, we have energy, mass, field, all this. These are concepts, and what they do is use them as mediators in mathematical physics. Action at a distance, that's a big problem. Okay, action at a distance, especially for pull. Mathematical physics has never discovered or invented the force of pull, and neither have any of the dissonants out there because they all use particles. Ultimately, they all use particles. They use the wave, which is made of particles. What is a wave? Waves are just vectors or particles that are moving up and down. So it's always particles, discrete particles. And in quantum mechanics, they say, well, they're particles, but particles are not particles. They're not the classical corpuscle. Particles are more numbers, values. That's all they're shaking around, numbers. And so, how do you do the physical interpretation of action at a distance with concepts? And you can't. There's only one way of doing it, with elongated invisible objects. Okay, that's the only way. If you want to pull on a horse, you got to put a rope around them, pull. We can all understand that. But if you say you're going to pull by, throwing rocks at them or pulling rocks, no, it doesn't work. You can't pull on a horse by having a whole bunch of discrete rocks and you pull on the rocks. Okay, there's no way of doing that. That's an irrational explanation. And so, no, if you want to do action at a distance, whether you do entanglement, gravity, magnetism, you had better have elongated mediators. Okay? Physical interpretations, they dismiss them as philosophy, ontology, and so why do all these folks up there, these great celebrities, why do they do philosophy? I mean, they call themselves physicists. Okay, if you say physics is math, do math. Well, if they did, everybody would switch channels. That's what they would do. So they don't do equations. They do philosophy, what they call philosophy, and then they do irrational philosophy. When you question that, they say, well, we don't understand it either, and then it's philosophy anyways. So what are these people good for? I mean, what do we need them for? To entertain us? I think, you might as well watch, beauty contests or something else, right? Okay, and then they dismiss rational definitions as semantics and word salad. That's another one. When you question their definitions, they say, well, now you're doing semantics. You're trying to win this argument on the basis of semantics. We're not trying to win any argument. We're just trying to make sure that we offer a rational interpretation for how this universe works. And these people cannot give you a rational interpretation. They can only give you irrational interpretations. What's irrational? To use a concept as an object. To use mass and say it's a rock. To use energy and say you're going to transfer energy. To say field and that you're going to vibrate the field or shake it or, whatever. Energize it. And bending of time, what is all that nonsense? So this is the issue. Okay, so where do we put this dark energy thingy to begin with? Okay, first of all, in physics, we do not use adjectives in front of objects. Okay, we cannot say black energy or red energy or, jumping energy. We can't use like that. No adjectives or adverbs in front of nouns. Nouns are all like this, that, rock, tree, house. You point and you name. You can't say red house. There's no such thing as a red house in physics. It's house. Okay? Red is irrelevant for presenting the object. You can't say the white cat or the dead cat or the live cat as in Schrodinger's equation and his cat analogy there. No, you point and you name. It's got to be, no adjectives or adverbs in front of the noun. Nouns don't need adverbs or adjectives when presented in physics. Okay? And so dark energy, we don't have to look at the word dark. We look at word energy. Is energy a physical object? Is it a thing? Can we talk about energy as a thing and say we're going to transfer energy, for example, right? And here it is under the rope model. We have this universal movie. And for those of you who are new here, you will see that you either have static concepts, which are on the top, and they occupy a single frame. All we have in a single frame is objects with locations. That's all we have, known as existence. And at the bottom, we have all these words that require at least two frames, if not more usually, right? They are dynamic concepts. So the ones on the top are static concepts. The ones on the bottom are dynamic concepts. And where do we find energy? Well, we find it on the bottom. Energy is a dynamic concept. Energy, in fact, is measured in different measurements that they have out there, ergs and so on, kilo ergs and so on, kilowatts and so on. They have all these different measurements, and they treat them as physical objects. Okay, and so here you have energy. Energy is at the bottom. It's a dynamic concept. So we're not going to be talking about a thing. We're going to be talking about an abstraction, a dynamic concept. Okay, energy. So whether it's dark or light, bright or whatever they want to put in front of the word energy, it doesn't matter because we're not talking about a thing. That's the main point. But that's how they define it. Here's the definition of energy. Energy, quantitative, this is out of the Wikipedia, by the way, quantitative property that is transferred to a body. So they're transferring properties. I mean, I don't know, are they selling land or what is this property that they're transferring? The deed? I mean, what sense does this make? Quantitative property that is transferred to a body. What is quantitative? It says a physical quantity. They like to put the word physical. Physical is a synonym of objects. So what do you mean a physical quantity? Just say a quantity, a number, that's it. Or simply quantity. Yeah, quantity. Forget about the word physical. Don't put the word physical there, it's confusing. Is a property of a material or system that can be quantified by measurement. Yeah, it's a quantity. It's a number. That's all it is, an amount with a unit. That's all that energy is. Now you see property, it's a synonym of quantitative because you look it up, it says physical property is any property, I like that, property is a property, right, that is measurable whose value describes a state of a physical system. Essentially, quantitative and property are synonyms. So we have a quantitative quantity or a property property. That's what they just said. And that is transferred to a body. What is a body? Well, it says a collection of matter. What is matter? A bunch of bodies. So we learn nothing from these definitions, and you can see how little they've put their brains to work to defining these terms. And that's when they accuse you saying, oh, you're doing semantics. You're trying to win an argument by semantics. Now we're showing that these definitions are ridiculous. They have no place in science, let alone in physics. That's where the problem starts. They don't have good definitions or definitions at all for any term. All they have, see, when you have that equal sign in math, that's not a definition. That says that the guy over here on one side is equal to the expression that's on the other side. That's all it is. But they're not telling you what the words mean. Okay, so math does not have definitions through equations. The equal sign in an equation is not a definition, but that's the way they think of it. Okay, when you criticize that, they say, oh, you're doing semantics, word salad. Okay, here we have what is dark matter? Well, I'm sorry, dark energy. Before we get to that, we need to find out what dark matter is because dark energy is what's going to be on the outside of dark matter, so to speak. Okay, here we have good old Liney. He's going to tell us what it is. Okay, he says dark matter, particles. That's what they are. They think of dark matter as particles. And they're ultra heavy, they're dark, but they're not dark. They call them dark matter. Why do they call it dark matter? If they're invisible, translucent, transparent. See, you see a galaxy there, and they say dark matter is that halo that you see around the galaxy. And you know that when the astronomers look at these galaxies, they see the stars right through the so-called dark matter, like if it wasn't there. So if you can see right through it, we're not talking about dark because then you would not be able to see them. No, we're talking about translucent, invisible, transparent, whatever you want to call it. You can see right through the dark matter as if it weren't there at all. Okay, so think about that. And so they say to the astronomer, go look for it. Okay, so the guys point out there and they say, astronomers trying to look through them, trying to find them through telescopes. People at CERN are trying to discover this dark matter by running experiments. Yeah, it's invisible, ultra heavy, but they're going to try to find it, by running experiments. If it's intangible, invisible, translucent, how do they plan to find it? With an experiment. Experiments is for eyes and touch, eyes and hands. And so these people are saying we're going to find it even though it's invisible, intangible, dark, meaning really translucent, transparent, or one of those, invisible, right? How do they plan to find it? Through an experiment. And the way they do, they plan to detect it indirectly by the effects it has on something else. That's their logic. Okay, we're going to get that in a minute. Okay, so here we have, here's the definition of this dark energy thingy. And this is out of the Wikipedia. It says, dark energy is an unknown form of energy. Great. That affects the universe on the largest scales. The first observational evidence for its existence came from measurements of supernovas, which showed that the universe does not expand at a constant rate. Rather, the universe expansion is accelerating. Okay, so they say the universe, which is a concept, right, is accelerating. It's like saying love is accelerating or expanding, right? What's the problem? Well, the problem is that, concepts don't expand. That's one issue. And the question is whether it's space that's expanding or the matter in the universe is exploding, which is a better term than expanding. We're not saying that matter expands. We're saying that the matter, in other words, every atom or every star, every galaxy is running away from all others. We're saying matter is simply becoming more separated by distance from all others. Okay, and that's not expansion. So the question is, why did they use the word expansion and with the word universe when universe is a concept and we don't know if they're referring to space or to matter? Which one are they talking about? Matter cannot expand. You can say it's like a hand grenade. The debris is just flying away from each other. That's not expansion. Okay, but then the question is whether space is a thing and whether space can expand. That's the other issue. And then the third issue would be, what is it expanding against? If space is a thing and it's expanding, what is on the outside of it? What is it pushing up against? Those are the questions you got to keep in mind, okay? Measurements of the cosmic microwave background radiation, suggest the universe began in a hot Big Bang from which general relativity explains its evolution and the subsequent large-scale motion. Okay? Without introducing a new form of energy, there was no way to explain an accelerating expansion of the universe. Okay, so they created this dark energy thingy to explain the expansion of the universe. Okay, so they're thinking of a balloon. The balloon is expanding. They say, what's driving that expansion? Well, with a balloon, you put air in there and it gets bigger. Okay, we all understand that. And that's what they're saying, that air that you push in, that's the dark energy. That's what's blowing the universe outwards. And what is it blowing outwards? Space, because they're treating space as a physical object. Okay, so this is where we're getting to. We need to determine whether space is a physical object, and if so, what's outside of it, because an object is that which has shape. Hopefully there's something giving contrast to the ball. Okay, something on the outside. Okay, here we have one fellow, and he's very popular in Quora. His name is Victor Thoth. And Thoth, by the way, was the god of math of the Egyptians. So we have our own god in our own days. His name is Victor Thoth. And what does good old Vic say? Well, he says the following. He says, the missing matter is called dark matter. The remaining stuff with negative pressure is called dark energy. Okay, so if dark matter is what surrounds a galaxy, why does it stop? Why does it continue all the way to whatever? Well, because if we had dark matter all throughout the universe, it would be be gravitationally pulling. And they need to explain the opposite. They need to explain why the universe is expanding, not why it's contracting. Okay, so dark matter, they only sprinkle it around the galaxies for whatever reason. It stops there. What continues is dark energy, and that's what's pushing the galaxies away from each other. That's their notion of this universe that they've created for us. All this is based, all of this is backed by pretty solid, rigorous mathematics. Again, to make equations, numbers, mathematics for something that you can't see and that you assume is made out of particles is too quick a step. You can't move to that until you've identified the invisible stuff first. You need to know whether it's a rat or a snake before you put your equations to work. Okay, because if you start doing equations on rats and it turns out it's a snake, well, maybe you wasted a lot of hundreds of years on nonsense. Okay, and that's where all these people stand. Yet at the same time, we have not the faintest clue as to what these dark thingies really are. Love that. So he has no idea what it is, but they're already doing equations on it. Okay, and here he continues. He says, "What is dark energy? Dark energy could be just an artifact of the so-called cosmological constant." You know, that was Einstein's biggest blunder, as he called it. Or the potential energy of a so-called scalar field. Or maybe just the energy of the quantum vacuum. I believe that we need to find ways to actually detect these dark thingies before we can say anything definite about their nature. I'd like to... he was right there. Yeah, you first need to identify these thingies before you do a lot of equations and, convince the public that they exist. Perhaps these dark thingies do not even exist. They are mirages of sorts because we are doing the math using the wrong theory of gravity. Okay, so you can see some of these people doubt what has been already proven and served to the public as a done deal. And they say dark energy, we've proven it. Dark matter, we've proven it. Black holes, we've proven it. We've proven everything. Big Bang, we've proven it. Entanglement, we prove it. They prove everything. They proved everything, and they say, look, we don't know what they look like. We don't understand it either. But Father Universe, he speaks a different language than we do. He doesn't have to think like we do. And that's the kind of answers you get from him. That, we'll never figure it out because we're not intelligent enough, intelligence, right? So we're not intelligent enough to figure it out. And all we can do is search and describe. And that's it. That's all these people have to offer. And then when you get these celebrities, they don't even do that. They don't even do the math or descriptions. What they do is they do explanations, irrational explanations. When you question them about it, they say, well, you're doing semantics and it's philosophy anyways. We don't care about it. So why do they hire physicists to do philosophical work on TV and on interviews and so on? If they're going to talk about equations, talk equations. If you're going to talk philosophy, as they call it, then bring a philosopher in. You would think. Okay, here we have, this is the situation. We have dark energy on the outside, which is that black stuff, you could say, right? And dark matter is the stuff that surrounds a galaxy. And again, the problem here is that we can see right through the dark matter, stars which are in that region far away. So it's completely translucent, completely invisible, okay? And so I'm not sure how they're ever going to detect that dark matter or dark energy because it's all, or black holes because they're all invisible. So they're always detecting it indirectly on the assumption that it has to do with mass and gravity, okay? Because if it has nothing to do with mass or gravity, then we have a different universe. Okay, keep that in mind. Okay, so what is it that they propose? It looks something like this. Let me put it in motion here. Okay. And this is their universe. They say we have this expanding balloon. That's our universe. All the galaxies there. And within each one of the galaxies, you find dark matter around, surrounding each galaxy. And then the black stuff that pushes everything outwards is the so-called dark energy. That's the anti-gravity. Okay, so you know this is the universe that they sell out there to everybody, and a lot of people already know this by heart. And what you see, all these celebrities, they talk about this over and over and over and over again. They talk about black holes, what it's like to fall into a black hole. You get spaghettification and all this other good stuff. And so the question is, are we going to hear this for the next million years? The same thing over and over and over again, that they found the first black hole, the first rotating black hole, the biggest black hole, the smallest black hole. What is this? What we need to find out is, how this universe works. I need to know why this pencil falls to the floor and not to the ceiling. That's what I need to figure out. And they can't answer that question. They say, we don't know. We're still investigating. We're researching. Okay, how long are you going to take? How much money you need for your investigation? Okay, so here we have good old Stephen Hawking. He tells us that there's nothing outside the universe, because if dark energy is pushing outwards, the question is, what is it pushing out against? Fortunately, these people have answers to all these questions. Here you have Stephen Hawking. He says, the universe is not infinite in space. Okay, I thought it was infinite. Now he's saying that it's not. Okay, but neither does space have any boundary. Sounds like a contradiction. He's telling you in that first sentence there, he says, the universe is infinite and it's also finite. Okay, he covered all the bases there. How did he do that? Well, he says, gravity is so strong that space is bent round onto itself, making it rather like the surface of the earth. So he thinks of space, of the universe, as a ball. Okay? And look what he's going to do. This is going to be his explanation. He says, it is possible for both space and time to be finite without any edges or boundaries. Okay? Especially the word boundary there, because he's going to talk about no bounds, unbounded, etc. If one keeps traveling in a certain direction on the surface of the earth, one never comes up against an impassable barrier or falls over the edge. Well, good old Stevie here, he's confusing the issues. On the one hand, he's trying to talk about structure. And he says, look, the universe is like the ball, like the earth. It's a ball. It's a sphere. Okay? Okay, we all understand that. It says it's finite. Okay, so far so good. We have that black stuff outside the earth, and that's, why the earth is not infinite, because there's this backdrop we call space that serves as, like a cover, okay? But then when he talks about bounded, he uses the wrong word. He's talking about running incessantly around a ball and saying you encounter no stop sign. And that's not unbounded. That's called incessant walking. He's no longer talking about structure. Now he's confusing, he's mixing, not even apples and oranges. He's talking about apples and running. That's what he's talking about. And he says, look, unbounded means you can run around the earth and never encounter, a fence. Yeah, that's called incessant running. It's not unbounded. But when he uses the word unbounded, which is very crucial in this argument, he's suggesting that the universe, right, because he's talking about the universe, is both finite and infinite. The finite part we all understand, it's a ball. Okay, great, so it's got a surface. But he says it's unbounded because you can run around the surface forever. And so, yeah, again, he's comparing more than apples and oranges. He's comparing apples and running, apples and swimming. He doesn't even know what he's talking about. He's confusing the issues here. Either we talk about structure or what we do. Okay, he's comparing nouns and verbs. And he calls the verb unbounded. Okay, no, it's incessant because he's talking about walking or running or whatever. Okay, here's another fellow who explains how the universe can be infinite without any problem. Without having something outside of it, okay? Because this is what they're trying to show. They're trying to show that the universe is both finite and infinite, and this is how this guy explains it, okay? And this is Richard Muller, Dickie Muller, and he says the universe doesn't have to be expanding into anything in order to expand. No kidding. Okay, let's see, how does he explain it? I know that sounds ridiculous. Absolutely, Dickie. It's totally ridiculous what you just said. But he has an explanation. He says, suppose you have a long piece of rubber going all the way to infinity. Okay, that piece of rubber represents the universe. Okay, the rubber has marks on it every inch. Now stretch the rubber until the markers are 2 inches apart. It still goes to infinity, but it has expanded. In other words, he's talking about infinity, which is a word that irrational people use in math. Okay, they talk about infinity because they're talking about numbers, and they kind of, do this sleight of hand where they put the word infinity in physical terms. They push the word infinity into physics. That's where the problem is. Okay, and that's one of the problem. The other one is that he says long piece of rubber. What do you mean long piece of rubber? Long piece of rubber is not the same thing as infinite piece of rubber. Okay, if it's a piece, then it's a object and it's got shape, meaning it's surrounded all around by something, for example, or nothing in this case, by space. That we can understand, but he says it's a long piece of rubber, but it's infinite. It goes all the way to infinity. Well, then it's not a piece of rubber because we can't see the shape of the rubber. Okay, so either it has shape all around, or it's infinite. And if it's infinite, it's not an object because we don't know what we're talking about. We don't know what that is. Is it growing? Is that why it goes to infinity? So he's got to resolve that, but he just does a sleight of hand and he doesn't even notice what he's saying. And he says it represents the universe. In other words, he's trying to say that the universe is a physical object and it's finite, but it's also infinite because, we don't know where it stops, okay? And that's not the issue. The issue is you have to visualize it for us and draw it on the board. And for that, you have to have a shape. So you can say, look, that ball there, that's the universe. Well, that ball is not infinite. And again, we're not talking about running around the ball. We're talking about the object that you're pointing to. Okay, so those are the things you got to keep in mind. Physicists think of space not as emptiness. Yeah, I know, that's not physicists. These are known as mathematicians. But similar to a piece of rubber. But they don't call it rubber. They call it the vacuum. Particles in physics are just vibrations of the vacuum. Absolutely love it. And this guy's a teacher, a professor at Berkeley. This is what he teaches, this nonsense. Okay, he says the vacuum is a thing, and when it vibrates, we call those particles. The vacuum can expand. Okay, so we have nothing expanding now. Okay, vacuum is nothing and expand, but he says it's something, right? Just like the piece of rubber. Okay, and again, what did he say the rubber was? Infinite, right? So he says the vacuum is infinite. It's a physical object that is infinite, right? But because it goes all the way to infinity, it doesn't need more space. A clever way to say it is that there's lots of room at infinity. That's clever, but it doesn't really explain anything. Yeah, all these people, they have no clue whatsoever. They don't even know what they're saying anymore. And where's the problem? The problem is, again, they're trying to give a physical interpretation to their equations. And in their equation, they have all these infinities, zeros, all that stuff that has nothing to do with physics. But they casually transport it or extrapolate it into physics, the physical world, the structural world, the world of objects, and they say, oh, infinity, so the rubber is infinite. The universe is infinite. That's what they're saying. Because they're thinking mathematical terms, and they think they can just step over the line from math into physics and, it's okay, no problem. Okay, so I like Feynman's, another Dickie, who essentially, tells us what it's all about. Okay, he really puts the icing on the cake. Here's the corollary. Okay, listen to good old Feynman. He was a Nobel Prize, I think, 1965. Okay, this is what he has to say. One might still like to ask, how does it work? What is the machinery behind the law? Yeah, that's what we want to know, Dickie. No one has found any machinery behind the law. No one can explain any more than we have just explained. No one will give you any deeper representation of the situation. We have no ideas about a more basic mechanism from which these results can be deduced. Yes, physics has given up. It must be recognized that this is a retrenchment in our earlier ideal of understanding nature. It may be backward step, but no one has seen a way to avoid it. Okay, so at least he said something which is correct, which is a little more truthful, saying they don't know. That's what he's saying. All these Dickie Muller, Dickie Feynman, none of them have any clue how this universe works. Why? Because they never figured out that in order to understand how the universe works mechanistically, causes, mechanics of how this universe works, how does gravity work, how does magnetism work, entanglement, all this other good stuff. If you want to understand how it works, you need to identify the invisible, intangible objects that Mother Nature uses to do stuff like this. If you say there's nothing there because you can't see it or touch it, first you have the wrong definition of object. It's that which has shape, not that which you can see or touch. And then you are doing not physics, you're doing witchcraft. You're explaining using black magic. If you say there's nothing there with which Mother Nature, affects things at a distance. If there is no such thing as action at a distance has to have a physical mediator that we can't see or touch. It's got to be an elongated mediator because that's the only way to produce pull, the only force that mathematical physics has never discovered to this day.